Question 1. The box and whisker plot for a set of data is shown. What is the median of this set of data? So the median is this line that's inside the box. Points to 30. Option C, median is 30. Question 2. A car is traveling at 95 kilometers per hour. How far will it travel in 2 hours and 30 minutes? So each hour we're covering 95 kilometers. So it certainly cannot be option A and it cannot be option B. So it has to be more than twice 95 kilometers. 2 hours and 30 minutes is 2.5 hours worth of travel. So 95 multiplied by 2.5 hours. And we get 237.5 kilometers. Option D. Question 3. The graph shows the relationship between infant mortality rate, deaths per thousand live births, and life expectancy at birth in years for different countries. What is the life expectancy at birth in a country which has an infant mortality rate of 60? So what we do, we identify the infant mortality rate first, the axis that corresponds to that, which is the x-axis. We find where 60 is, which is here. What we do is get a ruler, okay, project up until it touches the line, and then we project across to the y-axis. Okay. And that value there looks like 68. Answer A. Question 4. A factory's quality control department has tested every 50th item produced for possible defects. What type of sampling has been used? Let's have a look at the options. Quantitative is not a type of sampling, that's a type of data. So it's certainly not D. We're testing every 50th item, so there's nothing random about that. So it's certainly not A. Stratified, well, that implies that we're surveying or sampling data from a large group that is composed of smaller groups, such as, for example, year groups in a school. It's got nothing to do with that. There seems to be a pattern here. It's every 50th item. So when there's a pattern in the sampling, we tend to call that systematic. So it's option C. Question 5. In a survey of 200 randomly selected Year 12 students, it was found that 180 used social media. Based on this survey, approximately how many of 75,000 Year 12 students would be expected to use social media? So what we really want is the fraction of this 75,000 that's expected to use social media. And we need to use our sample to be able to determine that. So from 200 students sampled, 180 used social media. Now, that's the fraction of the 75,000 who are expected to use social media. Multiplying those together, 180 on 200 multiplied by 75,000, and we get 67,500. So that's option B. Question 6. Tom earns a weekly wage of $1,025. He also receives an additional allowance of $87.50 per day when handling toxic substances. What is Tom's income in a fortnight in which he handles toxic substances on 5 separate days? So there's two things going on here. First of all, we want to find out Tom's income in a fortnight. We have a weekly wage of $1,025. So let's work that out first. So $1,025 per week, we're going to multiply that by 2, and that gives us his fortnightly wage, but we need to also add in the additional allowance of $87.50 per day. And he handles that on 5 separate days. So let's add on the allowance. So it's $87.50, and that's going to be calculated across 5 days. Let's enter this in, 1025 multiplied by 2 plus 87.50 multiplied by 5. Press SD to get it into dollars and cents. 2487.50. 2487.50. Okay, so I might just write the answer here as well, just for your benefit. Option D. Question 7. It is given that I equals 3 on 2 mr squared. What is the value of I when m equals 26.55 and r equals 3.07, correct to 2 decimal places? So this is just direct substitution, and let's just substitute in the known values. So I is equal to 3 over 2 multiplied by m, and m happens to be 26.55, multiplied by r squared, so that's 3.07 squared. So that's what I'm going to enter in now in the calculator. So 3 on 2, I'm writing it as is, so as I've written it, 26.55 multiplied by 3.07 squared, and we get 375.35. Go to 2 decimal places. Option A. Question A. The diagram shows a right angled triangle. What is the value of theta, correct to the nearest minute? So this is just basic trigonometry. There's our theta. This is our opposite side. This is our adjacent side. Opposite over adjacent, that's going to be the tan ratio. So tan theta is equal to opposite over adjacent, so that's going to be 5.3 over 1.9. Theta is going to equal inverse tan, so that's shift tan on the calculator, 5.3 over 1.9. So let's enter that in now. Okay, so shift tan, got to have the negative 1 there. Okay, fraction, 5.3 over 1.9, close bracket. And now we press the degrees, minutes, seconds button, this button here. Okay, so, and it's 70 degrees, 17 minutes. Okay, so option B. Question 9. What is the value of x in the equation 5 minus x over 3 equals 6? Now there's 2 ways we can do this. Either you can substitute in each of these 4 values into the equation and see that it equals 6, or we can just solve the equation, and it's probably perhaps the easier thing to do. Let's multiply the right hand side by 3. So that's going to be 5 minus x is equal to 3 times 6, which is 18. So let's move 5 over to the other side. So negative x is equal to 18 minus 5. So negative x is equal to 18 minus 5, which is 13. Therefore, x is equal to negative 13 if you multiply both sides by negative 1. So the answer is 9A. Question 10. A single amount of $10,000 is invested for 4 years, earning interest at the rate of 3% per annum, compounded monthly. Which expression will give the future value of the investment? So 2 things we need to concern ourselves with. The interest rate per annum, compounded monthly, means the interest rate has to be divided by 12. It's interest rate per month, not per year. There's only 2 options that have the interest divided by 12. So it cannot be A and it cannot be B. Now, the other thing to look at is the number of compounding periods. We have one option here that has 4 compounding periods, another one that has 48. Let's go back to the question. we have 4 years worth of compounding, but compounded monthly, which means 12 times per year. 4 times 12 is equal to 48. So it's going to be option D. Question 11. A new car was bought for $19,900 and 1 year later its value had depreciated to $16,300. What is the approximate depreciation expressed as a percentage of the purchase price? Now, key word is depreciation. We talk about depreciation as a loss of value. So how much value was lost? So 19,900 minus 16,300. So that's the loss of value. That's the depreciation over the original purchase price, which was 19,900. And we multiply that by 100 to convert it into a percentage. So let's enter that into calculator. So 19,900 minus 16,300. So that gives us the loss of value over that year, over the original purchase price, 19,900. Multiply that by 100 and we get 18%. Option A. Question 12. Which of the data sets graphed below has the largest positive correlation coefficient value? So it certainly can't be A, because that's a correlation coefficient of 0. So that's gone. It can't be B, because that's a negative correlation coefficient. In fact, that's a correlation coefficient of 1, because the dots sit perfectly on the line. So this is R is in fact equal to -1, not 1. Let's have a look at D. Okay, there's a positive trend, but the dots are fairly, I guess relatively speaking, far away from the line compared to, say, option C, where the dots seem to show a positive trend, but seem to sit closer to the line compared to option D. So it's most certainly option C. Question 13. The heights of Year 12 girls are normally distributed with a mean of 165 centimeters and a standard deviation of 5.5 centimeters. What is the Z-score for a height of 154 centimeters? Now, 154 centimeters is less than the mean of 165 centimeters. That immediately implies that the Z-score has to be negative. So it can't be option D or C. So if you had to guess, obviously A or B. We can use the formula. Z-score is equal to the raw score, which is 154, minus the mean of this set of data, which is 165, over 5.5. Okay, entering in that expression in the calculator, 154 minus 165 over 5.5, and we get -2. Option A. Question 14. Kate is comparing two different models of car. Car A uses fuel at the rate of 9 litres per 100 kilometres. Car B uses 3.5 litres per 100 kilometres. Suppose Kate plans on driving 8,000 kilometres in the next year. How much less fuel will she use driving car B instead of car A? So what we need to do is work out how many litres of fuel the car's going to use over 8,000 kilometres. So we're going to use the unitary method here. So let's have a look at car A first. So let's work it out as in terms of the amount of fuel per kilometre. So 9 litres divided by 100 kilometres, but then we're going to multiply it by 8,000. And that gives us the amount of fuel that car A is going to use over 8,000 kilometres. So let's work that out quickly. 9 divided by 100 multiplied by 8,000, and we get 720 litres of fuel. Okay, so this is for car A. What about car B? We're going to do the same thing as well. So 3.5 divided by 100 multiplied by 8,000. Okay, and we'd expect a significant difference here actually. So 3.5 divided by 100 multiplied by 8,000, and we get 280 litres of fuel. So the answer is the difference between those two numbers. So 720 minus 280. We get 440 litres. Option B. Question 15. The faces on a 20-sided die are labelled 5 cents, 10 cents, 15 cents, and so on, up to $1. The die is rolled once. What is the probability that the amount showing on the upper face is more than 50 cents, but less than 80 cents? So more than 50 cents means 55 cents, 60 cents, 65 cents, 70 cents, and 75 cents. So 1, 2, 3, 4, 5 outcomes out of a total of 20, since it's a 20-sided die. 5 on 20 is just 1 on 4, so the probability is 1/4, option A. Question 16. The benchmark for annual greenhouse gas emissions from the residential sector is 3,292 kilograms of carbon dioxide per person per year. A new building planned to house 6 people has been designed to achieve a 25% reduction on this benchmark. What is the maximum amount of carbon dioxide per year to the nearest kilogram that this building is designed to emit when fully occupied? So we know that there's 3,292 kilograms of carbon dioxide emitted per person. Okay, so there are 6 people and there's this much carbon dioxide. So let's multiply those two together. 6 people, each one emitting 3,292 kilograms per year. But there's going to be a 25% reduction as well. So there's only 3 things we have to consider here. So reducing that by 25%, we could multiply that, bit of a shortcut here, by 75%, because that's when you take off 25%, you have 75% remaining. Let's multiply all that together. 6 times 3,292 multiplied by 75%. Okay, and we get 14,814. Okay, so it's going to be option D. Question 17. The graph of the line with equation y equals 6 minus 2x is shown. When the graph of the line with equation y equals x plus 3 is also drawn on this number plane, what will be the point of intersection of the 2 lines? Now, this could either be solved using algebra, or we could just draw in the line. Now, let's draw in the line y equals x plus 3. That has a y-intercept of 3, so it will be there. And it has a gradient of 1. So that means it's a line that kind of does this, right, in this direction. That means that it's going to cross the x-axis at x equals -3. Now, if we get a ruler and just mark in approximately where this line's going to go. Okay, so just take care with this. Okay, and that'll give you some idea of where the 2 lines in fact intersect. So that's going to be this point here. So that looks like x equals 1, y equals probably 4 actually. Yep, it's probably closest to 4 there. 1, 4. So option B. Question 18. A skip bin is in the shape of a trapezoidal prism with dimensions as shown. What is the volume of the skip bin? So this is a prism, which means the volume is given by the formula V equals area of the cross section multiplied by the height or the depth. So the area of the cross section is a trapezium, and that is found by taking the mean of the parallel sides, so 3.6 and 2.4. So this is this trapezium there. Okay, so it's going to be 3.6 plus 2.4 over 2 multiplied by the perpendicular height of the trapezium, or the face of this, which is the cross section, multiplied by the depth, which is 1.5. Okay, so entering in all of that, let's see what we get. 3.6 plus 2.4. So we're getting the average of the parallel sides, multiplied by 1.2, multiplied by 1.5, and we get 5.4 cubic meters. Option A. Question 19. Young's formula shown below is used to calculate the dosage of medication for children aged 1 to 12 years based on the adult dosage, where D equals the dosage for children aged 1 to 12 years, Y is the age of the child in years, and A is the adult dosage. A child's dosage is calculated to be 20 milligrams based on an adult dosage of 40 milligrams. How old is the child? Now, if you like, rather than wasting time trying to rearrange the formula, this is a multiple choice tactic that you can use. You can substitute the responses in the original equation, okay, and what you should hope for is that one of these should give you an answer of 20 milligrams. So let's try that. Okay, let's try the first one. Okay, so 6 times 40 over 6 plus 12, and we don't get 20. Let's try the next one. Okay. 8 plus 40 over 8 plus 12, and we get 16, but we want 20 as the answer. Let's try 10. 10 times 40 over 10 times 12, and we're getting 18.18, but we still want 20. Yeah, but we are getting closer. So let's try 12 times 40 over 12 plus 12. The answer is 20, and that equals 20 there. So the answer is option D. Question 20. A pentagon is created using matches. By adding more matches, a row of 2 pentagons is formed. Continuing to add matches, a row of 3 pentagons can be formed. Continuing this pattern, what is the maximum number of complete pentagons that can be formed if 100 matches in total are available? So what we can do here is to form a table of values. I might just draw it here. Okay. Okay, and we have, let P be the number of pentagons and M the number of matches. So we have 1, 2, 3 pentagons. So when we have 1 pentagon, we have 5 matches. When we have 2 pentagons, okay, if you count the number of matches there, we have the original 5 plus 4 gives us 9. Now 3 pentagons, okay, you have the 9 matches originally from the 2 pentagons. We're adding another 4 matches, and that gives us 13. Okay, so the formula is going to be number of matches is equal to 4 times the pentagons, or 4 times the number of pentagons, and the reason for that is because for every increase in the number of pentagons, for every increase of 1, it's an increase of 4 matches. It's like a gradient, so it's gradient of 4. But this isn't complete. When we have 1 pentagon, so 4 times 1, okay, that gives us 4. We're meant to have 5 matches, but 4 times 1 gives us 4, so we have to add 1 each time. So let's check it quickly. 2 pentagons times 4 gives us 8, plus 1 gives us 9, so that's correct. What about 3 pentagons? So 4 times 3, that gives us 12, plus 1 gives us 13, so that's correct. So we can use this formula now. So we're given here that, that we have 100 matches. Okay, so let's solve this. 100 is equal to 4p plus 1. So we need the number of sort of whole pentagons that we can form. Subtract 1 from the left-hand side. So 99 is equal to 4p. Okay. So we're going to divide 99 by 4. So p is equal to 99 over 4. And we get 24.75 pentagons. But in terms of the number of whole pentagons, you don't round this. It's going to be 24 because 0.75 of a pentagon is not a whole pentagon. So the answer is B. We get 24 whole pentagons, or complete pentagons. Question 21. The length of a netball court is measured to be 30.50 meters, correct to the nearest centimeter. What is the lower limit for the length of the netball court? So in order to answer this question, we need the precision, so the smallest unit of measure. Then we're going to work out the absolute error. So the smallest unit, okay, and it looks like it's measured in 0.01 meters, or in steps of 0.01. That's what nearest centimeter means, in fact. So it's in fact 0.01. That's the second decimal place there. Okay, so I'm going to leave it in meters. So the absolute error is half of that. Half times the smallest unit of measure, or the precision. So if you multiply that together, so half, again, I'm using a calculator because it just, under exam pressure sometimes you can get a mental blank. It's just best just calculate it. 0.005. So you don't want to make a mistake with the decimal places here. So that's equal to 0.005. Now, to get the lower limit for the length of the netball court, we take the measurement here, which is 30.50, minus this absolute error, 0.005, and let's see what we get. So 30.50 minus 0.005, and we get 30.495. So that's going to be option C. Question 22. A concrete water pipe is manufactured in the shape of an annular cylinder. The dimensions are shown in the diagrams. What is the approximate volume of concrete needed to make the water pipe? So this is an example of finding the volume of a composite solid, where we take the volume of the larger cylinder, the outer cylinder, and we subtract the volume of the inner cylinder. Now, there is an algebraic shortcut to this, but let's just work it out by first principles, just something that's easy to understand. So let's work out the volume of the outer cylinder, or the large cylinder. Okay, that's going to be AH, so that's going to be pi r squared h. And the large radius is 0.35 plus 0.1. That's going to be 0.45 squared, that's pi r squared, multiplied by 2.8 to get the volume. And we're going to subtract the smaller cylinder. Pi times 0.35 squared multiplied by 2.8. Okay. So let's enter that in and see what we get. Pi multiplied by 0.45 squared multiplied by 2.8 minus pi multiplied by 0.35 squared multiplied by 2.8, and we get 0.7037, and the solution that's closest to that is option C, 0.70 cubic meters. Question 23. Now, this question has been replaced because we no longer deal with data capacity in the current syllabus. So I've replaced it with this question. How many milliliters are there in 2 gigaliters? So this is really just about knowing your metric unit conversions and also the metric unit prefixes, giga, mega, kilo. So doing the conversion, I might just do the working out on the calculator. So if that's 2 gigaliters, converting that to megaliters, we multiply it by 1,000. Megaliters to kiloliters, multiply it by 1,000 again. Kiloliters to liters, multiply it by 1,000 again. And liters to milliliters, multiply it by another 1,000. And we get 2 times 10 to the power of 12 milliliters. Option D. Question 24. A deck of 52 playing cards contains 12 picture cards. 2 cards from the deck are drawn at random and placed on a table. What is the probability, correct to 4 decimal places, that exactly 1 picture card is on the table? So we can do a quick tree diagram, a probability tree diagram that is, to help us visualize this situation. So we've got picture card and non-picture card. Okay, so that's a P bar, which is non-picture card. We can draw another picture card, non-picture card, picture card, non-picture card. So this is an example of drawing a card without replacement. So To draw a picture card, we have 12 over 52. Non-picture card would be 40 over 52. And that's 12 plus 40 gives you 52. Now, if we draw one card, we've got 51 cards left. So these probabilities are going to be over 51. And I might just do it here, over 51, over 51. Okay, so if we've drawn a picture card, it means that we've got one less picture card, so we're going to have 11 there. Okay, and non-picture cards, we're going to have 40 still left to choose from. Now, with this branch, we've drawn a non-picture card, so instead of having 40, we've now got 39. And we've still got 12 picture cards here. Now, we're asked for the probability of having exactly one picture card. So that's going to be P bar, so we need that probability there, or P bar, P. So that's non-picture card, picture card. So those two probabilities. Okay, so that's going to be 12 over 52 multiplied by 40 on 51. And this one is 40 on 52 multiplied by 12 on 51. And we're going to add those two values together. Okay, so 12 on 52 multiplied by 40 over 51 plus 40 over 52 multiplied by 12 over 51. We get 80 on 221, 0.36199. So we need to round this value to 4 decimal places. So it's going to be 0.36120. In fact, the closest answer is going to be option D. Question 25. In the circle, center O, the area of the quadrant is 100 square centimeters. What is the arc length L correct to 1 decimal place? Now, the way we're going to answer this question is to treat it as if it was a whole circle. That means instead of the area being 100 square centimeters, let's pretend we're talking about the whole circle. So we need to find the radius first. This is what we need to do. Find the radius, and then we can use that to then find the arc length. So let's pretend then that the area is equal to 400 square centimeters. So 400 is equal to pi r squared. Let's solve this for r. So 400 over pi is equal to r squared. Let's take the square root of both sides. So square root of 400 over pi is equal to r. R is equal to, okay, let's enter this in and see what we get. So square root of 400 over pi. And we'll use a few decimal places there. So r is 11.28379. I think 5 decimal places is plenty there. Now let's find the arc length. So arc length, okay, so L is equal to 2 pi r. But we're only talking about 1/4 of the circle, so we're going to multiply that by 1/4. So that's going to be 2 multiplied by pi, multiplied by the radius we just found, which is 11.28379. And then we're going to multiply that by 1/4 because we're dealing with 1/4 of a circle. You could alternatively, you can divide that by 4. It's the same thing. Okay, so let's enter that in and see what we get. 2 pi times 11.28379 multiplied by 1/4, since we're dealing with 1/4 of a circle, and we get 17.724. Okay. 17.724, and the closest answer we have there is option C. Question 26a. Electricity costs 27 cents per kilowatt hour. How much does 20 kilowatt hours cost? So we take the cost per kilowatt hour, which is 27 cents, multiply it by 20, and we get $5.40. Question 26b. Toby's mobile phone plan costs $20 per month, plus the cost of all calls. Calls are charged at the rate of 70 cents per 30 seconds or part thereof. There is also a call connection fee of 50 cents per call. Here is a record of all his calls in July. How much is Toby's mobile phone bill for July? So first of all, Toby has to pay $20 per month regardless. So let's start with that. Secondly, he's made 3 phone calls in July, and each phone call has a 50-cent connection fee. So we've got 3 lots of 50 cents. Now let's analyze each of the calls. So his first call is a 20-second call, which falls within the first block of 30 seconds. So there's going to be 70 cents for that call. The second call on the 12th of July is 40 seconds, so that takes up one block of 30 seconds plus a little bit of the next block of 30 seconds. So there's 2 lots of 70-cent blocks that are used. Finally, the 23rd of July, okay, we have a 2-minute 15-second phone call. 2 minutes, that's 4 blocks of 30 seconds. Okay, so each minute is 2 lots of 30 seconds. So there's 4 lots of 30 seconds plus 15 seconds. That makes it 5 lots of 30-second blocks. And each 30-second block is worth 70 cents. And all we've got to do now is just add that all up. Okay, so let's do that. 20 plus 3 lots of 50 cents plus 70 cents for the first call plus 2 lots of 70 cents for the second call plus 5 lots of 70 cents for the third call, and that gives us a grand total of $27.10. Question 26c. A farmer needed to estimate the number of goats on his property. He tagged 80 of his goats. Later, he collected a random sample of 45 goats and found that 16 of these had tags. Estimate the number of goats the farmer has on his property. So let's write this as a ratio first. So we have 80 tagged goats to some unknown number is equal to the ratio of the tagged goats to the total number of goats in the sample. So in the sample of 45 goats, 16 were tagged. So that's going to be 16 to 45. Okay. Now what we can do is we can express it as 2 equivalent fractions, in fact. So we could write it as x over 80. Okay, so second term over the first term is equal to 45 over 16. Now let's solve for x. X is equal to, we can move the 80 over, multiply the 80 by the fraction 45 over 16. Okay, we can evaluate this expression now. So 80 multiplied by 45 over 16, and we get 225. Therefore, estimated number of goats equals 225. Question 26d. A sewer pipe needs to be placed into the ground so that it has a 2-degree angle of depression. The length of the pipe is 15,000 millimeters. How much deeper should one end of the pipe be compared to the other end? Answer to the nearest millimeter. So what we need to find is that side there. And we're just going to use basic right angle trigonometry. Here's our theta. That's our opposite side. This is our hypotenuse. So we could write sine of 2 degrees is equal to opposite over hypotenuse. That's 15,000. Making x the subject of the formula, x is equal to 15,000 multiplied by sine of 2 degrees. And we get 523.49. Okay, but it says to answer to the nearest millimeter, so we can round that to 523 millimeters. Question 26E. Sam purchased 500 company shares at $3.20 per share. Brokerage fees were 1.5% of the purchase price. Sam is paid a dividend of 26 cents per share, then immediately sells the shares for $4.80 each. If he pays no further brokerage fees, what is Sam's total profit? So I think the first thing we should think about is, what do we mean by profit? So profit is equal to the income minus the cost, okay, or the costs involved. So let's have a think about the income. So how much did Sam earn? So he earned 26 cents per share. So let's start off with that, multiplied by the number of shares. Okay, so we had 500 shares, plus what he sold the shares for. So $4.80 per share multiplied by 500. So I might just put that in brackets here just to make it a little bit clearer. And then we're going to subtract the cost. So minus, what's the cost now? He bought 500 company shares, $3.20 per share. Okay, so $3.20 multiplied by 500. I'm just going to put that in brackets as well. So I'm going to put this in one large bracket there. Plus what? Brokerage fees, 1.5% of the purchase price. So the purchase price is $3.20 multiplied by 500 multiplied by 1.5%. So all of that, this line here, is the cost, or the cost incurred to Sam. So let's work that out now, and we can enter all that into the calculator all at once. Okay, so let me just brighten that a little bit there. Okay, so 0.26, 26 cents per share multiplied by 500 shares. Okay, plus, now he sold the shares for $4.80, and there's obviously 500 of those shares, times 500. Now we need to subtract all the expenses, or the costs involved. So he paid $3.20 per share, and obviously multiply that by 500, plus 1.5% of the purchase price for brokerage. So that's $3.20 multiplied by 500 multiplied by 1.5%. And we get $906 profit. Question 26F. The area chart shows the number of goals scored by 3 hockey teams, A, B, and C, in the first 4 rounds. So part 1, how many goals were scored by Team C in round 1? So let's locate round 1. So that's this first label there, round 1. Now, along the y-axis, measuring how many goals are scored by a particular team is really the difference between that particular team and the team before it. That's how we read an area chart. So if looking at Team C, we can see that that's 9 goals here, but it's actually not 9 goals overall. You've got to subtract 5 from that. So 9 minus 5, that gap gives you the number of goals scored. So 9 minus 5 is equal to 4 goals scored. Okay, so we're talking about this gap here is 4. Part 2. In which round did all 3 teams score the same number of goals? So that implies then that the gap between all these teams, and also including the x-axis, should be identical. And I'm looking straight at round 3. You can just sort of see it there, that the gap between the x-axis and Team A is 2. Between Team A and B is 2 as well, 2 goals. And between B and C is also 2 goals. So 2, 2, 2. In which round? Round 3. And that's it. Question 26G. Rachel bought a motorcycle advertised for $7,990. She paid a $500 deposit and took out a flat rate loan to repay the balance. Simple interest was charged at a rate of 7% per annum on the amount borrowed. She repaid the loan over 2 years, making equal weekly repayments. Calculate the weekly repayment. So I think the first thing is we need to work out what the principal is, how much she actually borrowed. So we know that she bought a motorcycle for $7,990, so let's work out the P. So P is equal to $7,990 minus her deposit. Okay, so that's a cash deposit paid up front, which means that the principal borrowed, okay, is $7,490. So now she's going to pay over 2 years, 7% per annum on the amount borrowed. So let's work out the interest that is going to be charged. So I is equal to PRN, okay, so that's $7,490 multiplied by 7% per annum multiplied by 2 years. So 7% per year multiplied by 2 years. So the interest owed, okay, is going to be 7,490 multiplied by 7% multiplied by 2, and we get $1,048.60. Now, if we add the principal and the interest together, that's the total that she must repay over 2 years. So is equal to 7,490, the original principal borrowed, plus the interest 1,048.60. Okay, so 7,490 plus 1,048.60, and we get 8,538.60. Now that's going to be paid back in equal weekly installments. Now we can either use 1 year is equal to 52 weeks, or we can use 52.18. Now the sample solution that's given in the HSC, or the NESA supplied sample solution, uses 52 weeks. We're not told in the question whether to assume 52 or 52.18, so let's just assume 52. So, okay, so total number of repayments is equal to 52 repayments per year. We're going to multiply that by 2. Okay, so 52 times 2, that's equal to 104. Okay, and the amount of each weekly repayment is equal to the total amount to be repaid, which is 8,538.60, divided by the total number of payments, which is 104. Okay, so 8,538.60 divided by 104, and we get $82.10 per week. Question 27A. Jamal surveyed 8 households in his street. He asked them how many kilolitres of water they used in the last year. Here are the results. Part 1, calculate the mean of this set of data. And part 2, what is the standard deviation of this set of data correct to 1 decimal place? So we can use stat mode for this. So just brighten that display a little bit. Press mode, mode 2, stat, and then 1 var, so option 1. Let's enter in this data. So 220, 105, 101, 450, 37, 338, 151, and 205. Press AC. Now shift 1, okay, that brings up the stat menu, and we go option 4, so press that. Okay, so option 2 now, X bar, so that's the mean, and it's going to be 200.875 kiloliters. And the standard deviation, shift 1, option 4, var, and option 3. Press equals, and that's going to be 127.357. Just make sure that we round this correctly. It says to 1 decimal place, so that's equal to 127.4 kiloliters. Question 27b. Now, this question I was going to originally replace, but I'm going to answer this question just for the sake of completeness and also just to demonstrate another use of metric units, but this time talking about data capacity. So how many 20 megabyte files can fit on a 3 terabyte external hard disk? So really we need to work out how many megabytes a terabyte is, or 3 terabytes for that matter, and then how many lots of 20 megabytes fit in the megabyte equivalent of 3 terabytes. So let's convert terabytes to megabytes first. So 3 terabytes, right? And to convert that into megabytes, we need to convert it into gigabytes first. So we're going to multiply this by 1024. It's kind of a bit strange that we don't multiply it by 1000, but when you're talking about bits and bytes and megabytes and all that kind of thing, it's actually multiplying or dividing by 1024, which is kind of bizarre, but it does. There are reasons for that. So that converts it into gigabytes. Sorry, multiplying it by 1024 converts it then into megabytes. So let's work that out now. So 3, we'll maybe get it out of stat mode first. 3 multiplied by 1024 multiplied by 1024 again, and we get 3145728. So 3145728. Now to work out how many 20 megabyte files fit in this space. So that's in megabytes. So let's divide that by 20. 3145728. Dividing that by 20. Okay, so I could just use my previous answer. And we get 157,286.4. So 157,286.4. But we're talking about whole 20 meg files. So this 0.4 doesn't make any sense. So this is really, we round down 157,286, 20 megabyte files. Question 27C. A table of future value interest factors for an annuity of $1 is shown. An annuity involves contributions of $12,000 per annum for 5 years. The interest rate is 4% per annum, compounded annually. So part 1, calculate the future value of this annuity. So 5 years is the time period, so we need that row there. And the interest rate is 4% per annum, and we need this column there. Okay, so the factor that we need to multiply by is that one there. So the future value of the annuity is you take the contribution, 12,000, multiply by the interest factor, which is 5.4163. Okay, so future value interest factor there. Multiply those two values together, and that will give you the future value for that time period and that interest rate, which is 64,995 and 60 cents. Part 2, calculate the interest earned on this annuity. So let's take the future value. So we know that in the end we're going to end up with $64,995.60, but we need to subtract the total principal, I guess is probably a good way to describe it. We're contributing $12,000 per annum for 5 years. Okay, so that's $12,000 per annum times 5 years. So this is our contribution, which is actually about 60,000 if you multiply those together. Anyways, we could just enter that in directly into the calculator. So 64,995.60 minus $12,000 per year times 5 years, which is the actual contribution, how much money that's gone into the annuity, and we end up with $4,995.60. Question 27D. Island A and Island B are both on the equator. Island B is west of Island A. The longitude of Island A is 5 degrees east, and the angle at the center of Earth O between A and B is 30 degrees. Assume radius of the Earth is 6,400 kilometers. Now we need to add this assumption in because this is a question from a previous syllabus. So in order to make it a bit more accessible and be able to answer it with our current syllabus, we need to state this assumption. Part 1. What is the longitude of Island B? So Island B is to the west, which means that in order to find the longitude of B, we need to subtract 30 degrees from the longitude of Island A. So Island A is 5 degrees east, okay, and we treat east as a positive, and we're going to move in the negative direction, 30 degrees, and that gives us negative 25 degrees, and we treat negative 25 degrees as 25 degrees to the west. Part 2. What time is it on Island B when it is 10 a.m. on Island A? Now again, because we're moving in a westerly direction, the time on Island B is going to be behind the time on Island A. But what we need to work out is what 30 degrees represents in terms of hours, given that the Earth takes 24 hours to rotate through 360 degrees. So let's work out what 30 degrees represents in terms of hours. So 30 degrees out of 360 degrees, that's a fraction of the full circle, multiply that by 24 hours. How many hours does that represent? 30 divided by 360 multiplied by 24, and we get 2 hours. Okay. So the time on Island B is equal to the time on Island A, which is 10 a.m. Subtract 2 hours time difference, and that gives us 8 a.m. on Island B. Part 3. A ship leaves Island A and travels west along the equator to Island B. It travels at a constant speed of 40 kilometers per hour. How long will the ship take to arrive at Island B? Give your answer in days and hours to the nearest hour. So the first thing we need is this arc length, AB, and we need to use our assumption here that the radius of the Earth is 6,400 kilometers. So I'm going to add that on the diagram. Okay. And we're going to treat OAB as a sector of a circle because we're dealing with the equator. And the equator is what we call a great circle. So it's like a full circle or the maximum size circle that basically goes around the Earth. Okay. Well, it's one of several great circles. That's the main one. That sort of goes around the Earth. Okay. So let's work out the distance first. Okay, and we're going to use the circumference of a circle formula, which is 2 pi r. So 2 pi multiplied by 6,400, but then we need to multiply it by the fraction of the circle that we're dealing with, which is 30 out of 360 degrees. Okay, so let's enter this in. So 2 pi multiplied by the radius, 6,400, multiplied by the fraction of the circle, 3,351 kilometers. I'm going to round it to maybe, I might just write the full answer, 0.32164. Okay, just in the interest of maintaining some accuracy. Now the time it takes for the ship then to travel this many kilometers, is given by the distance, so 3351.032164 divided by the speed of the ship, which is 40 kilometers per hour. Okay, so I'm just going to use the previous answer on the calculator. Okay, so it helps not to clear the screen sometimes. And you get 83.7758.041 hours. 83.7758.041 hours. But we want the time in days and hours. So in order to convert that into days, we're going to divide that by 24. Okay. So it's important to show you working. Okay. And we've already worked that out, which is 3.490658504. Okay, days. So that's, in fact, in terms of days and hours, that's equal to 3 days plus, now, 0.49065 and so on. We need to convert this decimal part here into hours because that's still in days. So that's going to be 0.4906588504. Multiply that by 24 hours. So that's equal to 3 days plus, okay, so what I'm going to do is just a bit of a shortcut. If you subtract 3 from that, that gives you just the decimal part. Multiply that by 24, and we get 11.7758 hours. And rounding that to the nearest hour, because that's what the question asks for. Okay, so that's equal to 3 days and 12 hours. Question 27E. Reese is drinking low alcohol beer at a party over a 5-hour period. He reads on the label of the low alcohol beer bottle that it is equivalent to 0.8 of a standard drink. Reese weighs 90 kilograms. And the formula is provided here because in the older syllabus, or in the previous syllabus, the formula was given in a formula sheet. So I've provided it here in the question. What is the maximum number of complete bottles of the low alcohol beer he can drink to remain under a blood alcohol content, BAC, of 0.05? So what we need to do is solve this equation somehow, where N is the number of standard drinks, H is the number of hours drinking, and M is the mass of the person drinking. So this is the formula for the BAC for a male. So we want the BAC to be 0.05. Okay, so I might just do it here, 0.05, okay, is equal to 10N. So we need to work out how many standard drinks that's going to be equivalent to in order to maintain 0.05 minus 7.5H. H is the number of hours drinking. So that's multiplied by 5 over 6.8 M. So that's 6.8 multiplied by Reese's mass. So what we can do now is just clean this up a little bit. Okay, so we might evaluate some of these values. So 0.05 is equal to 10N minus, now 7.5 multiplied by 5 is 37.5 over 6.8 multiplied by 90, and that's 612. Now we need to solve for N. So how many standard drinks is that? So let's make N the subject of the formula. So let's multiply 0.05 by 612. Okay, so 0.05 multiplied by 612 is equal to 10n minus 37.5. Now we can add 37.5 to the other side, so this minus 37.5 becomes a plus, multiplied by 612 plus 37.5 is equal to 10n. Okay, we might as well evaluate the left hand side since before it gets too out of hand. So 0.05 multiplied by 612 plus 37.5, and we get 68.1 is equal to 10n. And that means that n is equal to, we divide that by 10, is equal to 6.81 standard drinks. Just ran out of space there. But we know that each bottle, so go back to the question, is 0.8 of a standard drink. So how many bottles is this? 6.81 standard drinks. Each bottle is 0.8. So the number of bottles this corresponds to is equal to the number of actual standard drinks, 6.81. Now each bottle is 0.8 standard drinks. Okay, so 6.81, okay, divided by 0.8, and we get 8.5125. Okay. Okay. But the question asks for what is the maximum number of complete bottles, and that's the key word. If you don't see that word there, you don't take into account that word, you'll be probably might be unlucky and get the answer wrong, in fact. So that's really the same as saying 8 complete bottles. So 8 complete bottles would keep Reese slightly under 0.05. To be at exactly 0.05, he would have to drink 8.5125. Okay, so this answers the question. Question 28a. Temperature can be measured in degrees Celsius C or degrees Fahrenheit F. The two temperature scales are related by the equation F equals 9C on 5 plus 32. Part 1. Calculate the temperature in degrees Fahrenheit when it is negative 20 degrees Celsius. So we just need to substitute negative 20 for C, or for the variable C in the equation. So F is equal to 9 multiplied by negative 20 all over 5 plus 32. Now, entering in that expression in the calculator. Okay, so 9 multiplied by negative 20 over 5 plus 32, and we get negative 4. Which is negative 4 degrees Fahrenheit. Part 2. Solve the following equations simultaneously using either the substitution method or the elimination method. So we could actually use either quite easily. In fact, it doesn't really matter. I think the substitution method may in fact work better here, and the reason for that is because of this second equation here. When you're solving an equation simultaneously using algebra, the idea is that we try and knock out one type of variable. You got the variable f and the variable c, and that complicates things. We just want one equation with one type of variable, either all letter f's or all letter c's, not a combination. Now, because f equals c, why don't we go back to equation number 1? Instead of writing letter f there, cross that off and we can put letter c in its place, since c and f are equal to each other. Okay, so using the substitution method, okay, we could write it as c is equal to 9c over 5 plus 32. Now, it can get quite complicated when you have fractions. So I guess the first thing to do is maybe multiply everything by 5, and that eliminates the fraction. So why don't we do that first? Okay, so 5 times c is 5c. 9c over 5 multiplied by 5 is just 9c. Okay, and 32 multiplied by 5. Okay, so 32 multiplied by 5 is 160. Now you have what appears to be a two-step equation. Let's collect the like terms. In fact, let's collect the variables on the left-hand side and keep the constant on the right-hand side. So the 160 stays put. Let's move the 9c over. So 5c minus 9c is equal to 160. So 5c minus 9c is negative 4c is equal to 160. And dividing everything by negative 4, okay, c is equal to, so I've just put it on the same line there to save a bit of space, is equal to 160 divided by negative 4, and that equals negative 40. Now, I'll just sort of complete it there. So therefore c is equal to negative 40. Now if c is equal to negative 40, what must f equal? Well, f equals c. Therefore, f also equals negative 40, since f equals c. Now there's a part 3 to this. It's on another page. Okay. So part 3, the graphs of f equals 9c on 5 plus 32 and f equals c are shown below. So there's the graph. So what does the result from part 2 mean in the context of the graph? Okay, so this is the result from part 2. Right, this result here, c equals negative 40, f equals negative 40. That's the result from part 2. In fact, just to quickly, I guess, just to demonstrate the idea, okay, if we extend this line a little bit further, so we're basically, what do you think is going to happen if I extend both of these lines as far as I can possibly go? What do you think is going to happen? The lines are going to, right? They're going to intersect, aren't they? So it's sort of going down into the question there, into the text. But the result from part 2 is a point of intersection. Okay. Okay. Of the two lines at the coordinate. What do you think the coordinate's going to be? Negative 40, negative 40, comma, negative 40. Question 28b. 5 people are in a team. 2 of them are selected at random to attend a competition. Part 1. How many different groups of 2 can be selected? So the way to visualize this would be to maybe think about a tree diagram. So you're going to choose 2 people from 5. So the first choice, you've got 1, 2, 3, 4, 5 people to choose from. But then you've chosen one person, you now have 4 people to choose from for your second person. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so on. So we've got 5 people to choose from in the first pick, 4 people to choose from in the second pick, because you've already chosen one person, but the order in which you choose the 2 people doesn't actually matter. So we've actually got to divide that by 2. So you could choose person A and then person B, or you could choose person B and then person A. It doesn't really matter. The question doesn't ask for a particular order. So that's going to be 20 divided by 2, which is equal to 10 different ways. Now, part 2. If Mary is one of the 5 people in the team, what is the probability that she is selected to attend the competition? And we could just think of it just using some basic probability. In fact, there's 2 situations that this could arise. Either Mary is chosen first. Right, Mary chosen first. and that's first, so that's out of the 5 people, so that's equal to 1/5. Or we could have the probability of Mary chosen second as the second person in the team, which means that she does not get chosen as the first person, and there's a 4/5 chance of that happening, because out of 5 people, there's a 4 on 5 chance that Mary doesn't get chosen first up, but she could get chosen as the second person, and in fact we're trying to find the probability of that. There's 1 of Mary out of 4 people. Multiplying those together, 4 on 5 multiplied by 1 on 4, and we get 1 on 5. So the probability that Mary is chosen is the sum of these two probabilities. So that's equal to 1 on 5 plus 1 on 5, which is equal to 2 over 5, which is equal to 0.4, or 40% chance. Question 28C. Michelle borrows $100,000. The interest rate charged is 12% per annum, compounded monthly. The monthly payment is $1,029 and the first repayment is made after 1 month. What is the amount outstanding immediately after the second monthly repayment is made? Now, the first thing we need to take into account is the compounding frequency. It's monthly, which means that the interest rate per annum needs to be converted into an interest rate per month. So let's work that out first. So R is equal to 12% per annum. Now, very convenient, dividing that by 12, and we get 1% per month. Now let's work out the amount owing after the first repayment, so after 1 month. A1 is equal to, first of all, the principal is $100,000, so that's what she has owing originally. The bank is going to add 1% interest, and the way we're going to do that is to increase 100,000 by 1%, and the easy way to do that is to multiply it by 1.01. And then we're going to deduct the monthly payment of $1,029. So let's see how much is owing after the first month. So $100,000, we're going to increase that by 1%, that's 1% per month interest, minus $1,029 in the monthly payment, and it's $99,971. $99,971. Now let's work out the amount owing in the second month immediately after the second payment is made. So A2, which represents the amount owing at the second month, end of the second month. We take what is owing at the end of the first month, so that becomes the principal of the start of the second month. The bank is going to increase that amount by 1%, so it's going to add its 1% interest, and then Michelle is going to pay $1,029 again. So let's work that out. So 99971, increase that by 1%, minus the monthly payment, and we get 99941 and 71 cents. So $99,941 and 71 cents owing. Just give it just a conclusion. Question 28D. Make y the subject of the equation, x equals the square root of yp minus 1. So we need to isolate the y. It needs to be on its own. So maybe the first thing I'll do is maybe swap the two sides around in the equation. The reason why is because I like the subject of the formula to be on the left-hand side. So why don't we start off with that? So square root of yp minus 1 is equal to x. Next thing I'm going to do is I'm going to square both sides, because it's kind of like you're trying to free this variable y. It's kind of like trapped, you know, sort of under the square root there. So let's do that. So that's yp minus 1 is equal to x squared. Okay, so that's squaring both sides. Now we need to basically move the terms that are furthest away from y. And the term that's the furthest away is the negative 1. So we're going to add that to the other side. Okay, so the minus 1, we move it over, becomes plus 1. So yp is equal to x squared plus 1. And lastly, because y is being multiplied by p, and we want p over the other side. So in order to move p over the other side, we need to do the opposite of what p is doing now, which is multiplying y. So we're going to divide the right-hand side by p. So it's going to be x squared plus 1 over p. Question 28e. A movie theatre has 200 seats. Each ticket currently costs $8. The theatre owners are currently selling all 200 tickets for each session. They decide to increase the price of tickets to see if they can increase the income earned from each movie session. It is assumed that for each $1 increase in ticket price, there will be 10 fewer tickets sold. A graph showing the relationship between an increase in ticket price and the income is shown below. Okay, so that's the graph. And the question continues on the next page. So I might just the graph side by side there. Yep. So part 1. What ticket price should be charged to maximize the income from a movie session? So we'll go back to the graph, and what we're interested in is obviously the vertex of this parabola. Okay. And that corresponds to the maximum income that can be earned. So we'll need a ruler. Okay. So if we project across, okay. So it's just one step below 2000. Now there are 1, 2, 3, 4. There's 5 intervals between 1,800 and 2,000. So there's a $200 difference. 5 intervals, that's $40 per interval. So 1, 2, 3, 4. 4 times 40 is 160. 160 plus 1,800 is $1,960. So the ticket price, what ticket price should be charged to maximize the income from a movie session? Each ticket currently costs $8. But the graph talks about an increase in ticket price. And the vertex of the graph corresponds to an increase in ticket price of $6. So the answer to this one would be $14 per ticket. So part 2. What is the number of tickets sold when the income is maximized? And this goes back to the original question. So a movie theatre has 200 seats. We'll see one ticket, one seat. And we know that when there's an increase in the price of tickets, for each $1 increase that is, there's 10 fewer tickets sold. So let's go now to the graph. Just go back to the part of the graph that corresponds to the maximum income, which is $1,960. So each $1 increase in ticket price is 10 fewer tickets. So let's set this up. We're starting off with 200 tickets originally, and we're subtracting how many lots of 10. So for every $1 increase, it's 10 tickets. 10 multiplied by, so we're talking about a $6 increase in price. Okay. Okay, so 200 minus 10 times 6 is equal to 200 minus 60, which equals 140 tickets sold when the income is maximized. So part 3, the cost to the theatre owners of running each session is $500 plus $2 per ticket sold. Calculate the profit earned by the theatre owners when the income earned from a session is maximized. So we'll need to use part 1 and part 2. So we know $14 per ticket, 140 tickets, and the cost is $500, obviously to run the movie, plus $2 per ticket sold. So profit is equal to the income minus the expenses. So the income, we already know what the income is. Okay, we can get that from the graph. In fact, the income maximized, when the income is maximized, okay, it's $1,960. So we can read that from the graph. Okay. Minus the expenses, and the expenses, okay, I'm going to put that in brackets, $500 plus $2 per ticket sold, so that's 2 times 140 tickets. Entering in that into the calculator. Let's see what we get. So 1960 minus 500 plus 2 times 140, so notice that's in brackets, it's 1,180. Okay, now just one quick side note. If you don't want to use the graph to work out that it's $1,960 when the income is maximized, if you work out that it's $14 per ticket, okay, I might just quickly calculate this. So $14 per ticket multiplied by the number of tickets sold, which is 140, is also 1,960. So that's just an alternative way of coming up with the maximum the maximum income. Question 29A. A new 200-metre long dam is to be built. The plan for the new dam shows evenly spaced cross-sectional areas. Part 1. Using 4 applications of the trapezoidal rule, show that the volume of the dam is approximately 44,500 cubic metres. So in order to use the trapezoidal rule to estimate volume, it's very similar to estimating area. We need to know the spacing between each of these segments. So if it's 200 metres, there are 4 of these segments, it's going to be 50 metre spacing between these segments, or between these cross-sectional areas there. So volume is approximately equal to, okay, so it's going to be 50 on 2. And we take the 2 areas on either side as being df plus dl. Okay, and that's actually from your formula sheet. So 0, so that area here is 0, plus this area, this cross-sectional area is 140, plus 50 over 2, 140, plus 270, plus 50 over 2, 270 plus 300, plus 50 over 2, 300 plus 360. So basically it's just 4 trapezoidal prisms really. So that's what we're what we're doing here. Entering all of that into the calculator. Okay, let's just brighten up the display. Okay, and 50 on 2 outside of 0 plus 140 plus 50 over 2, 140 plus 270. Just make sure your calculator entry is accurate. Okay, so don't go too fast. Just make sure that you don't make any silly mistakes here. Plus 300 plus the last one, 50 over 2, 300 plus 360. And that gives us 44,500 cubic meters. As required. Okay. Because we've been asked to show that this volume is approximately 44,500. So look at part 2. It is known that the catchment area for this dam is 2 square kilometers. Calculate how much rainfall is needed to the nearest millimeter to fill the dam. So we know how much water can fit in the dam, the capacity of the dam, 44,500 cubic meters. So when we talk about the catchment area now for this dam, think of it as basically the base of a rectangular prism. So I might just quickly sketch it here just for you to see what I'm about to do. Okay, just to visualize this quickly. Okay, and the base is 2 square kilometers. So what we need to find is we need to find the height of this prism so that the volume of this prism should equal 44,500 cubic meters. So the first thing we need to do is to change the base or the units of the base of this prism from square kilometers to square meters. So let's do that first. So 2 square kilometers. Now changing square kilometers to square meters, we multiply by 1,000 squared, not by 1,000 because we're talking about area now. So it's square units. Okay. So 2 multiplied by 1,000 squared is 2 million. Square meters. Now we need the volume of this prism, and we need the volume of this prism to equal 44,500 cubic meters. So we're going to set this up as an equation. 44,500 is equal to AH, so okay, multiplied by H. The reason why I had to change it into square meters is because the volume is in cubic meters, so I need all the dimensions in meters. Of course, we want the final answer to be in millimeters, but we'll save that till the end. Let's now solve for H. So H is equal to 44,500 divided by 2 million. Okay. So 44,500 divided by 2 million. Okay. And we get 0.02225. Okay. And that's in meters. So that's the height of this prism. So the height of this prism there is 0.02225 meters. But we need that in millimeters. So let's convert that to millimeters. Okay, we've got a large unit of measure. There's 1,000 millimeters in a meter. Let's multiply that by 1,000. And a quick shortcut is to move the decimal point 3 places to the right hand side. 1, 2, 3. So that's equal to 22.25 millimeters. And it says to the nearest millimeter question. So that's going to be equal to 22 millimeters. Correct to the nearest millimeter. So we need 22 millimeters of rain over this catchment area to fill the dam to this capacity. Question 29b. Sabrina's taxable income is $86,725 in a particular year. The table below is used to calculate her tax payable. In addition, she pays the Medicare levy, which is 2% of her taxable income. Calculate Sabrina's net income in that year. So let's work out, first of all, her tax liability, so how much tax that she's going to have to pay. All right, that's her gross income. Obviously, we find out the tax that she owes, we work out the Medicare levy, we take it away from her taxable income, and that will leave her net income. So, tax liability. Okay. And using her taxable income as our guide, 86,725. Let's locate the row that this belongs to from the tax table. So we're going to use this row here. Okay, so it's just under 87,000. Let's follow the rule then under the tax payable column. Okay, so she's going to pay $3,572 plus 32.5 cents for each dollar over $37,000. Okay, so now 32.5 cents for each dollar is really the same as saying 32.5% for each dollar over 37,000. So how much is she over 37,000? So that's worked out by the difference of 86,725 minus 37,000. Okay. So it's working that out. 3572 plus 32.5% multiplied by 86,725 minus 37,000. So that's the amount above 37,000. And we get $19,732.63, correct to the nearest cent. Okay. Now let's work out her Medicare levy. Okay. And that's 2% of taxable income. Of her taxable income, that's her taxable income there. So it'll be 2% multiplied by 86,725. Okay. Okay, and we get 1,734. $1,734.50. So her net income is found by taking her taxable income or her gross income minus or subtract the tax liability and then taking away the Medicare levy as well. So I might just put it here on this row. Okay. So 86725 minus 19732.63 minus 1734.50, and we get $65,257.87. Question 29C. A group of Year 12 students were surveyed. The students were asked whether they live in the city or the country. They were also asked if they have ever water skied. The results are recorded in the table. Part 1. A person is selected at random from the group surveyed. Calculate the probability that the person lives in the city and has never water skied. Now, with two-way tables, especially this kind of two-way tables, these are for non-mutually exclusive events, I like to add up all the rows, add up all the columns and get a total. And this will give us also the total number of people surveyed. So let's add up the first row, 150 plus 2,500, that's 2,650. 70 plus 800 is 870. Now adding up the columns, 150 plus 70 is 220, and 2,500 plus 800 is 3,300. Okay. Now what you should find is that if you add up that last row, okay, in fact 220 plus 3,300, so if you're under exam pressure and you don't trust yourself too much, just use your calculator, add them up. Okay, you get 3,520. But also check that the column, the last column, also adds up to the same amount too. 2650 plus 870, you get 3520. So we're happy with that. Now we can answer part 1. A person is selected at random from the group. Calculate the probability that the person lives in the city and has never water skied. Okay, so lives in the city, that's this row, and has never water skied, that's this column. So it's 2,500 of those surveyed. So 2,500 over the total number of people surveyed, which is 3,520. Okay. Okay, just enter into the empty calculator, and the calculator will simplify the fraction for you. So the probability is 125 over 176. Okay, so that was fairly straightforward. Part 2. A newspaper article claimed that Year 12 students who live in the country are more likely to have water skied than those who live in the city. Is this true based on the survey results? Justify your answer with relevant calculations. So what we need to do is compare kind of two subgroups, okay, or the two groups that make up this survey, this sample. So we have the city group and we have the country group. So let's have a look at the city group first. Okay, so the probability that they've water skied, okay, so lives in the city, we have 2,650 people. Okay, so probability that they've water skied. Okay. Okay, go back to the table again, just make sure we're doing the right thing. 2650, that'll be our denominator, because that's the number of people that live in the city. 2650. And of those, 150 have water skied. We're going to convert that into a percentage to make comparison easier. Okay, so 150 over 2,650, multiply that by 100, and we get 5.66%. Okay. Okay. And it is actually approximate, so I'm just going to indicate here that it's roughly 5.66%. And what about country? Let's compare that group. The country group. Probability that someone selected, the student selected, that comes from the country and has water skied. Okay, so lives in the country. How many students that live in the country that were surveyed? 870. Okay, so that'll be our denominator, 870. Of those 870, 70 have indicated that they've water skied. So it'll be 70 over 870. We're going to multiply that by 100 to convert it into a percentage. And we'll just round it to 2 decimal places. So that symbol just means approximately equal to. You might have seen it a squiggle like that as well. Okay, it means the same thing. So 70, okay, over 870, multiply that by 100, and we get 8.05%. Roughly 8.05%. So the probability, okay, for country students is higher than for city students. Therefore, newspaper claim is correct. Anything to that effect or to that wording should suffice. Question 29D. All the students in a class of 30 did a test. The marks out of 10 are shown in the dot plot. So part 1, find the median test mark. So the median test mark is just the middle score. We know that 30 students did a test, so we need the mean of the 15th and 16th scores. So just remember, with median, if there's an even number, you need the mean of the two middle scores. So let's count 15 scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So the median, okay, is equal to 4 plus 8 over 2, which is equal to 12 over 2, which equals to 6. Part 2. The mean test mark is 5.4. The standard deviation of the test marks is 4.22. Using the dot plot, calculate the percentage of marks which lie within one standard deviation of the mean. So we need to work out what that range is. So, okay, so the lower limit, okay, is equal to 5.4 minus 4.22. Okay. So 5.4 minus 4.22, and we get 1.18. Okay, let's work out the upper limit, which is equal to 5.4 plus 4.22, which equals to 9.62. So let's count the number of scores that lie between these two values. So we can't include 1 since the score of 1 is in fact less than 1.18. So it's from the 2s, okay, so from the mark of 2 onwards. And we can't include 10 since obviously 10 is greater than 9.62. So these are counting the scores, counting from 2 to 9. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we need the percentage of marks. Okay, so (13 on 30 multiplied by 100), and that gives us 43.33%. Correct to 2 decimal places. In part 3, a student states that for any data set, 68% of the scores should lie within one standard deviation of the mean. With reference to the dot plot, explain why the student statement is not relevant in this context. And it comes down to the shape of this plot, that for the student's claim, or for the student statement to say that 68% of the scores should lie within one standard deviation, that implies it must be a bell curve. Okay, so the data is not normally distributed. Okay, does not follow. Okay, so I use the bell curve in quotes, but it just highlights what we mean by that. So this is the bell curve. Question 30A. A set of data has a lower quartile, QL, of 10 and an upper quartile, QU, of 16. What is the maximum possible range for this set of data if there are no outliers? So this is a question that's based on the formula 1.5 multiplied by the interquartile range, subtracted from QL or added to QU, and that finds the boundaries for the outliers. I might just draw a quick diagram just to show you what I mean. So imagine, here's our number line. There's QL, and there's QU. Okay, this is the interquartile range, right? Basically from QL to QU. Now, if you multiply this by 1.5, okay, this interquartile range, and you add it to QU, okay, so adding this to QU, or you're subtracting this from QL, this gives you the boundaries of the outliers beyond these boundaries. So the first thing we need to work out is the interquartile range. Okay, and that's QU minus QL, so it's going to be 16 minus 10, okay, which equals to 6. Now let's work out 1.5 multiplied by the interquartile range, okay, and that's equal to 6 multiplied by 1.5, which is equal to 9. Now the outlier boundary, okay, and let's work out the lower one. Okay, so that's going to be QL minus 1.5 multiplied by the interquartile range. QL is 10. Okay, so we've got 10 to 16. So 10 minus 9, which equals to 1. And QU plus 1.5 multiplied by the interquartile range. QU is 16. So 16 plus 9, which equals to 25. So the range, which is what the question's asking, the maximum possible range, okay, so I'll just put here, right, the max range is equal to 25 minus 1. Right, where there are no outliers. Question 30b. The cost of a jewelry box varies directly with the cube of its height. A jewelry box with a height of 10 centimeters costs $50. Calculate the cost of a jewelry box with a height of 12 centimeters. So this is a formula, it's a direct variation formula, where it's going to be in the form y is equal to k multiplied by x cubed. Okay. And we need to find the value of k before we can then answer this question. Now we do have some data already. We know that a jewelry box with a height of 10 centimeters costs $50. So let's let x represent the height and y represent the price. So $50 is equal to k multiplied by 10 cubed. K is equal to 50 divided by 10 cubed. Hence, k is equal to, okay, let's work this out, 50 divided by 10 cubed, and we get 0.05. Now we can proceed to answer this question. Calculate the cost of the jewelry box with a height of 12 centimeters. So y is equal to 0.05 multiplied by 12 centimeters, and we need to cube that. Multiply all that together. So 0.05 multiplied by 12 cubed, and we have $86.40. So therefore, the cost is $86.40. Question 30C. The diagram shows the location of 3 schools. School A is 5 kilometers due north of School B. School C is 13 kilometers from School B. And angle ABC is 135 degrees. So part 1. Calculate the shortest distance from School A to School C to the nearest kilometer. Now, looking at this diagram, we have a triangle, we have 2 known sides and an included angle. That means it's cosine rule. So let's use that. So we need to find AC. So the cosine rule goes AC squared is equal to 5 squared plus 13 squared minus 2 times 5 times 13 multiplied by the cosine of 135 degrees. So let's work that out. We're not going to round it until the very end. Okay, so we have 5 squared plus 13 squared minus 2 times 5 times 13 multiplied by cos of 135 degrees. So AC squared is equal to 285.92388816. But we want AC. Okay, so just like with Pythagoras theorem, we need to take the square root of the previous answer. Okay, 92388816. So square root of our previous answer. Okay, and we get 16.9. Okay, however, we need to round it to the nearest kilometer. So 16.9 is equal to 17 kilometers to the nearest, correct, to the nearest kilometer. Okay, so I'm going to add this on to the diagram. Okay, so that's 17 kilometers. Let's have a look at part 2. Determine the bearing of school C from school A to the nearest degree. So this means that we need to find school C, the bearing of school C from school A. So we actually need this angle here. Okay. Now from north to south is 180 degrees. So in actual fact we need this angle there. Okay, angle BAC. So I'm just going to put a theta there. So if we can find that angle, we can add it to 180 degrees, we get the bearing. Okay. So this means then that we may have to look at another rule. Now let's see if we have some side angle pairs, because maybe the sine rule could work here. We have 17 kilometers opposing 135 degrees. So there's a known side angle pair. We have theta opposing 13 kilometers. So there's a side angle pair where one of the, the distance is known, which means that we can then use the sine rule to find theta. So let's do that. Okay. So, and we need to find an angle. So I'm going to write it this way. Okay. Sine 135 degrees over 17. Okay, so that's sine 135 over 17. Okay, that's a sine A over A is equal to sine of theta over 13. Okay, so that's sine of theta over 13 kilometers. Let's solve this. Okay, so sine of theta. Okay, I'm going to move the 13 over to the other side. So that's going to be 13 multiplied by sine 135 degrees over 17. Okay. And theta is equal to the inverse sine. Okay, so we don't want sine theta. We actually want just theta on its own. Okay, of all this. Okay, so 13 multiplied by sine 135 degrees over 17. Okay, so let's quickly work that out. So shift sine. Okay, and in fact, I'll do it this way. 13 multiplied by sine of 135 over 17. Okay, close brackets. We get 32.73. Okay, what? Just okay, 32 degrees, 44 minutes, in fact. Okay. So the bearing of C from A is going to be 180 degrees plus that angle we just found. Okay. Okay. Of C from A, okay, is equal to 180 degrees plus 32 degrees 44 minutes. Okay, so let's add 180 to that, and we get 212.733 degrees. Okay. Okay, but we need to round that to the nearest degree. So that's equal to 213 degrees, correct, to the nearest degree. Question 30D. In an investigation, students used different numbers of identical small solar panels to power model cars. The cars were then tested and their speed measured in kilometers per hour. The results are summarized in the table. The equation of the least squares line of best fit, relating the speed and the number of solar panels, has been calculated to be y equals 2.125x plus 2.0375. Part 1. What would be the speed of a car powered by 5 solar panels based on this equation? So y is equal to 2.125. Now x represents the number of solar panels, and we need to substitute 5 for x. So we're going to multiply 2.125 by 5 plus 2.0375, and just calculating the speed, 2.125 multiplied by 5 plus 2.0375. So it's just a simple substitution, and we get 12.6625 kilometers per hour. Okay. Now it doesn't say to round it, but we could round it to 2 decimal places, so I'm just going to leave it as it is. Part 2. Calculate the correlation coefficient R between the number of solar panels and the speed of a car. Now, this is where a formula is required, and I'm just given the formula down here. Okay, now this is in fact a formula given in an older formula sheet, so this question comes from an older syllabus. So this is the formula here. Gradient equals R multiplied by standard deviation of y scores over the standard deviation of x scores. Okay, so I've just written there that same formula here. So we know the gradient. Okay, the gradient of the formula is 2.125. So I'm just going to substitute in some of the values that we know, and we're going to solve for R. So the gradient is 2.125 is equal to correlation coefficient R multiplied by, now standard deviation of y scores. Okay, so we'll get that from the table. Okay, standard deviation of the y scores, which is the speed, so that's 2, over standard deviation of the x scores, and that's 0.8. Okay, now what we need to do is just rearrange this formula to get R. So 2.125, if we divide that by 2 over 0.8, okay, so it's just a simple rearrangement to make R the subject of the formula. So it's just basic algebra, really. Okay, 2.125, now we can just calculate or just evaluate the left-hand side, 2 over 0.8, and we get a correlation coefficient of 0.85. Okay, so therefore R is equal to 0.85. And how would you categorize this, the strength of this relationship and the direction? So this would be a strong relationship, a strong linear relationship, and because it's over 0.75, this would be a strong positive linear relationship. Question 30E. A solid is made up of a sphere sitting partially inside a cone. The sphere, center O, has a radius of 4 centimeters and sits 2 centimeters inside the cone. The solid has a total height of 15 centimeters. The solid and its cross-section are shown. What is the volume of the cone, correct to the nearest cubic centimeter? So we're only after the shaded region. So here's the cross section there. Well, first thing we might do is we might write down the volume of the cone. And the cone is a special type of pyramid, which means that it's going to be 1/3 AH, okay, which is equal to 1/3 multiplied by the base area of the cone, which is going to be circular. Okay, so that's going to be pi r squared multiplied by the height of the cone, which is h. So we really need to find two things. We need the r, the radius of the cone, and we also need the h, the height of the cone. So I think we can find the height of the cone easily enough. What we might do is we might just draw a radius here from the center of the sphere O, okay, and it's going to be equal to the radius anywhere else. Okay, that's actually one of the characteristics of a radius or radii, that the distance from O to anywhere on the circumference of the circle is going to be identical. So there's 4 centimeters. Okay, now this one's going to be 2 centimeters here, that's given. So from O to the horizontal dotted line, this one's also going to be 2 centimeters because 2 plus 2 gives us 4, which is also a radius. Now we can work out the height of the cone. So that's an easy mark to get. Okay, so might actually write it as height of cone just to make it a little bit clearer. Okay, rather than just writing h. So height of cone, h, okay, is equal to 15 minus, okay, so that's minus 4 minus 2. Okay, so it's going to be 15 minus 4 minus 2, and that then gives us the remainder. Okay, so I might actually just draw that arrow there so you can see what I'm doing. That's going to be equal to 9 centimeters. Okay, so we have this worked out now. Now we need the radius. Okay, so from this point, okay, so from this point here to this point there. Okay, and notice that we have a right angle triangle. Right angle triangle, we have a hypotenuse, we have one of the short sides, but the other short side is the one that we need, which is the radius of the cone itself. Okay, so this is the r that we need to find. Okay, so the radius of the cone, okay, which is r, okay, is equal to, now, to effect Pythagoras theorem, where we're trying to find one of the shorter sides. So we have the hypotenuse here, which is 4 centimeters, and we subtract the square of the other short side, which is 2 centimeters, all squared obviously. So hypotenuse squared minus 2 squared, so that refers to the hypotenuse in this short side here. Okay. Okay, and that's equal to 16 minus 4, okay, which is equal to square root of 12, or if you've evaluated it directly, okay, so you could have just typed it in directly here, so 4 squared minus 2 squared, and you get 3.4641. I might just write a few decimal places there. Okay, 3.464101615. It's probably a good idea to maintain accuracy right up until the very end, and then just round it correct to the nearest cubic centimeter. Now that we have the radius of the cone, so we have our r, okay, so volume of the cone is equal to 1/3 multiplied by pi multiplied by r squared. Okay, so that's going to be 3.464101615 all squared multiplied by the height of the cone, and we've worked that out to be 9 centimeters. Okay, and evaluating all of that. Okay, so 1/3, okay, multiplied by pi, multiplied by, now I can sort of save a bit of time here, that was the previous answer that was on my calculator screen. So we're going to square that, and then multiplied by 9. And we get 113.09733 ... So probably going a little bit beyond there. Okay, and then we can just round to the nearest cubic centimeter anyway, so that's going to be 113 cubic centimeters, correct to the nearest cubic centimeter.